All right, this lesson is about derivatives using data. One of your 6 free response questions on the AP exam will be a data problem. Okay, now it may not ask any of these questions that I'm going to show you on the lesson today because we're focusing solely on derivatives, but you will have a question that has a table of values and they will ask you some questions about that table. So you can count on that, and we will be doing data style lessons throughout the year. Okay. All right, so with this problem, we have water flowing into a tank over a 24-hour period. The amount of water in the tank is modeled by a differentiable function W for 0 to 24. T is measured in hours, and W of T is measured in gallons. Values of WT at selected values of time T are shown in the table below. All right, so this is the only information we know about W. All right, whatever they told us up here, basically that it's measured in gallons. They did tell us that it is a differentiable function, W. So we know W is differentiable on the interval 0 to 24. That will probably be something that's important later in the problem. And then we know the values of W at these specific spots. Okay. So part A says use the data in the table to find W of 8. So this isn't even really a calculus problem. This is just looking at the table. There's 8. 8 is T. W of 8 is 221. Using appropriate units, W of T is in gallons. All right, explain the meaning of your answer. So this we're going to use to practice writing a sentence that will get us all the points on this problem. So you never want to think about these sentences like, what's the least amount I can write and still get credit? Just think about it as, let me write my answer so perfectly that they have no choice but to give me the points. Okay, so explain the meaning of your answer. That we have an acronym for this. It's NUT. So N stands for noun. U stands for unit. T stands for time. So all of your explanations of what the meaning of your answer is in the context of the problem should include a noun, a unit, and the time. Okay, it doesn't have to be in that order, but those have to all be there. All right, so I would say W of 8 is the amount of water in gallons in the tank at T equals 8. Okay, so the noun is the amount of water in the tank. Okay, I stuck the U kind of in the middle of my noun. The U is gallons. I've got my unit there, I've got my noun there, and then the time is T equals 8. Okay, so as long as you have those 3 components, you have an answer that they have no choice but to give you the credit for. All right, part B. Use the data in the table to find W inverse of 257. So now this is the W value, and we want to find the T that goes with it. So 257 is right here. The T that goes with it is 12. So W inverse of 257 is equal to 12, and T is in hours. Okay, you actually can get away with not putting the units here because we are going to mention the units over here in our answer, but I usually just put it in both places. Again, remember, we want to write our answers so perfectly that they have no choice but to give us the credit. So it's not going to hurt, and it takes 1 extra second. So you're not going to run out of time on the test because you wrote the units in 2 different places. All right, so let's write our answer. W inverse of 257 is the time when there are 257 gallons of water in the tank. All right. So I forgot something, but I'll point out how I figured out that I forgot something. So where the NUT algorithm kind of fails is when your input is not a time. So sometimes they give you weird problems where input's not a time, or in this case where we were doing the inverse. So time was our answer, input was the gallons. So our time is actually the 257 gallons. because that's the input. All right, our noun is the time when there are 257 gallons of water in the tank. All right, now notice I forgot my units. All right, I wrote them over here, but I should say right here, I'm going to fit it in, is the time in hours when there are 257 gallons of water in the tank. Okay, so now I have my unit right here. I have my noun right there, and I have my time. Again, time in quotes. Really, this is the input here, the output here, and then your units as well. All right, part C. So parts A and B are not really calculus problems. You're not going to see that on a calculus test, certainly not on the AP exam. We're just practicing writing a sentence for our answer because that is required for you to be able to do on the AP exam. Letter C is a problem that you will see. Okay, I won't guarantee it, but this question, a question just like this, is on the AP exam most years. Okay, it was on last year's test. It was on the year before. So expect to see something like this. Use the data in the table to find an approximation for W prime of 15. Show the computations that lead to your answer. Using appropriate units, explain the meaning of your answer. All right, so we have gone over what a derivative is at this point. A derivative is a slope. So this is asking what is an approximation for the slope at t equals 15. So if you go up to your table, you're not going to see t equals 15 up here. All right, that's okay. T equals 15 falls right here. So what they're asking you to do, approximation is doing a lot of heavy lifting in this problem. What they're asking you to do is do an average rate of change. Remember, when we do a derivative, we take the average rate of change and we just make the interval smaller and smaller and smaller by doing a limit. So they're asking us to not do a limit, just find the actual average rate of change. And to approximate this particular value, we want to use the numbers that are closest to t equals 15. So we're going to use the 12,257 and the 16,294. And we're going to do an Algebra 1 style slope there. And that's going to be our answer. Okay, so W prime of 15 is approximately equal to, you almost never get points taken off for doing a straight equal sign, but anytime it's an approximation, you really should do a wavy equals. So that's what I'll be doing when we do approximations. All right, 294 minus 257. And then divided by 16 minus 12. All right, there's a thing on the free response called a safe stop. You never have to simplify your answers on the free response part of the test. Okay, this problem that we're doing today is mirroring a free response type of problem. So I want our notes to mirror that as well. Okay, so I'm done. I'm not gonna simplify this. You're only gonna cost yourself points because maybe you subtract something incorrectly. All right, and if I wrote equals 38 over 4, okay, which is wrong. It should be 37 over 4, I believe. Yeah, so that would be wrong. I would have, if I stopped right here, I would have had the right answer. But since I wrote this, I now have the wrong answer. Okay, they read with you as long as you write. So don't ever write too much. This is something we'll practice throughout the year. Okay, so we're not going to write that. We're going to leave our answer here. And then I'm going to put my units on my answer. The units on the numerator are gallons. And the units on the denominator are hours. So this is in gallons per hour. All right, so show the computations that lead to your answer. What that means for this problem is a difference quotient. So they want to see a difference and they want to see a quotient. So you have to have a subtraction and a division. Okay, so even if you chose to simplify, you have to show this step anyway, because that's showing your computations. So this gets you both a point for showing your computations, and it gets you a point for having the correct answer. So it does double duty. All right, so you have to write it anyway. Just stop there. All right, now the only thing we haven't done is explain the meaning of our answer. So I'm going to write another sentence just like we've been doing up here. So W prime of 15 is the rate of change. A derivative is a rate of change in gallons per hour. You could also write that as a fraction Didn't really leave a space there. Gallons per hour. Of the amount of water in the tank at t equals 15. All right, so we needed a noun. They're looking for this phrase, rate of change. And then of the amount of water in the tank is also part of our noun. Units, gallons per hour, time, t equals 15. As long as you have those three pieces, you have an answer that they can't do. They can't take a point away for. They have no choice but to give you credit for it. All right, part D is asking you to find the average rate of change over the interval 4 to 20. Okay, they even give us the formula right here. So this is W of 20 minus W of 4 over 20 minus 4. Show the computations that lead to your answer. We have a difference quotient. Okay, so this gets me the computation point, but this does not give me the correct answer point. Okay, you have to plug in the actual numbers from the table for the W's up here to get your answer point. Okay, so W of 20 is 327, and W of 4 is 184. So 327 minus 184 divided by 20 minus 4. Don't forget your units. Okay, this problem didn't specifically say show your units, but if units are given in the problem, it's always a good idea to put units on your answer. Okay, now this first thing I wrote, you actually don't have to write that. We would be fine because this does double duty, just like this did up here. It's a difference quotient, so that gets me the computation point. It's also the correct answer, so that gets me the answer point with my units attached to it. So if all you did was write this right here, you would be getting full credit on that problem. All right, for 0 to 24, must there be a time t when the tank contains 265 gallons of water? So this is asking about the existence of a value. Okay, the theorems that we learned in this class, they're called existence theorems. Okay, so we've only learned one so far, the intermediate value theorem, and so that's what we're going to use here. So what we're looking for is, do we have two values in the table, one value bigger than 265 and another value smaller than 265? Because if we do, then that means 265 has to have happened because it's in between those two values. Okay, so I go up to my table and I can pick any two values that do this, but I usually use the first one and the last one if those work. So 150 is smaller than 265. 357 is bigger than 265. So I know 265 falls in between those. So that's what we're going to do. Now, for the intermediate value theorem to apply, the function that we're looking at must be a continuous function. If a function is not continuous on the interval, then you cannot assume it takes on every value in between. So it has to be a continuous function. Remember that thing that I had us underline. W is a differentiable function. When we talked about differentiability, I told you about that contrapositive. Okay, we learned that if a function is discontinuous, that means it's not differentiable. Well, the contrapositive was if a function is differentiable, then that function must be continuous. Okay, you have to write that as part of your answer on this problem. So you are going to restate W is differentiable and therefore continuous on 0 to 24. Okay, so that they're looking for that. That's going to be a point. All right, then you need to show that 265 falls in between two values. Okay, so I'm going to do this all at once. W of 0 is equal to 150, which is less than or equal to 265, which is less than or equal to 357, which is equal to W of 24. Therefore, IVT applies. All right, so what's going to get you points on here? You have to state how you know the function is continuous. Continuous is the main word here. For IVT, a function has to be continuous, but how did we know it was continuous? Well, we knew it was continuous because they told us that it was a differentiable function. So you make that connection between differentiable and continuous, and you've gotten that point. You need to show that 265 falls in between two numbers in the table. Again, it doesn't matter which two numbers you choose as long as 265 is in the middle. So I chose 0 and 24 as my input values to give me those, but I could have chosen other ones. All right, and then you invoke the name of the theorem at the end. Okay, if you don't invoke the name of the theorem, you have to write that conclusion. Therefore, there's a value C on the interval 0 to 24 such that W of C equals 265. It's a mouthful. It's a lot to write. Okay, just invoke the name of the theorem. It's much simpler and cleaner, and we'll get you all the points. All right, again, this is an answer written so perfectly that they have no choice but to give us all the points on it. All right, they love to do this on these type of data problems. So they ask you a few questions about the table, and then all of a sudden on part C, okay, I realize it's part F on our notes, but we're doing some extra stuff for our notes today. They introduce a function. They say, hey, this function is the same thing as W in the table. Model for the amount of water in the tank is given by A of T equals that, where A of T is measured in gallons and T is measured in hours. Use your calculator to find A prime of 15. All right, so this is something we haven't done yet. This is one of the skills that you're required to know how to do on the calculator for the AP exam. You have to know how to find the derivative at a point. Okay, so we could actually do this by hand, but we're not going to. We are going to use our calculator. And so all you have to write on this problem is A prime of 15 equals, and then everything else is done in the calculator. So I'm going to pull that up. All right. We're going to go to a graph, and we're going to type in our function. So 1 over 225, parentheses. You have to use x in the graph, so negative x cubed plus 30x squared plus 1800x plus 33,750. Okay, can't see anything. That's okay. You could go to menu, window zoom, and then there's zoom fit right here, which usually works pretty well. Good enough for what we need it for, but you don't even really need to see the graph. You can go to Control Doc and add a calculator page, and then go to Menu, Calculus, Derivative at a point. Okay, on the CX calculators we have in class, it'll say numerical derivative at a point, and it'll be number 1. This is the CAS version, so it has some extra things the CAS does that the CXs don't do. So you've got that. Variables x is fine. 15 is our value. We're doing the first derivative, so we hit OK. And then you just type your function in. And the reason I typed it in a graph is so all I have to do is type in f1 of x right there. I'll give you my answer, and the answer is 9. So it's actually a whole number answer. You can also do this on the graph right here. If you go to Menu, Analyze Graph, and then dy over dx, that is another notation for derivative. So click that. It'll say position down here. So just type in 15, hit enter. There you go, 9.000. So this is equal to 9. And it's a derivative, so it's rate of change, which means we're in gallons per hour. And that's it. They don't say we have to explain our answer. Use your calculator. Oh, that's spelled wrong. Calculator. To find A prime of 15. And so that's all you would have to write on your paper. A prime of 15 equals that. You don't need to state what the derivative is, the function, because you're using your calculator. So don't do anything by hand that your calculator will do for you on a calculator question. All right, last one is use your calculator to find the average rate of change from 4 to 20. So this would be A of 20 minus A of 4 over 20 minus 4. Okay, it didn't specifically say to show the computations that lead to our answer, but it's always a good idea to make sure you're showing your computations. So I'm going to write that. That's my difference quotient. And then, I'm not going to calculate any of this by hand. I'm just going to type this whole thing right into my calculator, and it's going to give me an answer. Okay, so back to my calculator page. I'm going to hit Control divided by, it gives me a fraction. And then F1, once again, I'm using that function, F1 of 20 minus F1 of 4 divided by 20 minus 4. All right, I want decimal form, so I'm going to put a decimal point after that 4. So I make sure I get decimal form. There you go. 8.996. This 5 will round it up to a 6, or you could say 995. You can truncate which means just drop all the decimals after. So there are two acceptable answers, 8.995 or 8.996. I prefer to round, so I am going to put 8.996 as our answer. And again, our units, since this is a rate of change, will be in gallons per hour. So we showed the computations that lead to our answer. We have the correct answer with our units. So we're going to get full credit on that problem. All right, that'll do it. You have a worksheet on derivatives using data. Hope you enjoyed the video. I'll see you for the next one.